Okay, so in this video, we take a look at partial derivatives for functions of 3 or more variables. So when we're dealing with more variables, taking partial derivatives follows exactly the same rule, right? So you apply the ordinary differentiation rules to one variable at a time while treating all other variables as constant. So for example, let's take a look at this example here, where we're asked to find all the first order partial derivatives. So we have three variables, x, y, and z, right? So that means we want to find fx, fy, and fz. Okay, but before we get to that, let's rewrite this function in the following way. So the square root in the denominator I think of as being to the minus 1/2 power, right? So this is 2, and then in parentheses you have x squared plus y squared plus z squared. And again, the square root is in the denominator, so I think of it as the minus 1/2 power. And then this term minus x squared e to the xy over z. Okay, so let me rewrite it like that. And then now we can try to find the partial derivatives. So the partial with respect to x. So I'm differentiating with the variable x. Right, so this part I need to use the chain rule along with the power rule. So the derivative of the outside is the power rule. The inside stays exactly the same. And then I subtract 1 from the exponent, so that's minus 3/2 and times. And then now again the chain rule, so I have to differentiate inside. X is the variable, so the derivative of this is 2x. And these I just think of, so here I'm thinking of both y and z as constants, so the derivative of this goes away. So this part is just 2x. And then now I have minus, here I have x squared times the exponential, and both of these contain x. So for this partial derivative, I need to do the product rule, right? So derivative of one part at a time. So derivative of minus x squared is minus 2x times the exponential stays the same, and then minus the x squared stays the same times the derivative of the exponential is the exponential, but I have to do the chain rule. So when I differentiate inside, x is the variable, y over z is the constant coefficient, so that comes out. Okay, so that's what we get here. And then I can simplify this a little bit. So 2 times negative 1/2 is a negative. So negative times the 2x, so you get minus 2x. And then this part has a negative exponent, so I can write it like this. So x squared plus y squared plus z squared to the 3/2 power, but in the denominator. Okay, so let's take care of this part. And then this part here, this has the same exponential as this, so I can factor that out. And so what's left over, minus this 2x, and so I'm pulling the minus out so that this becomes a plus. And then where do I have x squared times y over z. And again, I'm factoring out this exponential on the right side, so you get exponential xy over z. Okay, so that's the partial with respect to x. So now let's take the look at the partial with respect to y. So going back to the original function here, so the first part needs the chain rule again. So 2 times negative 1/2. The inside stays the same. Subtracting 1, so this is minus 3/2. And then times the derivative of the inside. Now y is the variable, and this whole thing is a constant, so that goes away. This whole thing is a constant, so that goes away. So derivative of y squared is just 2y, and then minus the partial is with respect to y, so x squared I'm thinking of as a constant, so the derivative doesn't affect that. And then now the derivative of the exponential is the exponential, but then I have to apply the chain rule. So y is the variable, and so x over z is the constant coefficient. Okay, so we get this, and again we can simplify. So the 2 and the 1/2 cancel. I have a minus 2y, and then this thing has a negative exponent, so that goes in the bottom. This 2y I already put in the numerator, and then here x squared times x is x cubed. Okay, so that's the partial with respect to y, and then finally the partial with respect to z. So I have to apply the chain rule together with the power rule again. So 2 times minus 1/2, inside stays the same. Subtract 1 from the exponent, so that's minus 3/2, times the derivative of the inside. Now z is the variable, and x and y are constants, so you get 2z. And then the derivative here, I'm treating x as a constant, so it doesn't affect the minus x squared. The exponential, I need to apply the chain rule, so this times the derivative of the inside. Now z is the variable, and it's in the denominator, so I think of it as z to the minus 1. And then the derivative, the minus 1 comes down, so that's minus xy. And then the exponent is negative 1. Negative 1 minus 1 is negative 2. So I push it into the denominator as z squared. Okay, so that's the derivative of the inside here with respect to z. Okay, so now we can clean some things up. So the 2 and the 1/2 cancel. I still have this minus 2z over x squared plus y squared plus z squared to the 3/2. And then this part here, x squared times x is x cubed, y over z squared times the exponential. Okay, so that's the partial derivatives for a function with 3 variables.